So my obsession with ciphers was renewed after my brother died. This is just going to be our recursive function, and it's going to spit out the numeric core. Yesterday, I've almost located the family core within the vault. Unfortunately, the clues I was given are slightly ambiguous, and apparently a lot of people get stuck here. Guess what? Me included. Luckily, you guys were able to provide some hints within the comments of the previous episode, and with those, I think I should be able to do it. I'm Noel, a game designer and programmer, and this is my study, where I analyze games carefully. Welcome back to my blueprints journal here, which by the way is 153 pages long at this point. So in order to locate the family core, there is a total of 4 blue memos, which you guys confirmed that's all the clues I'm gonna get, and 3 of those we've already used. So there's only really 1 left that I still need to make sense of. Now I had a couple days to ponder over this, and I might have an idea of what to do. The one I'm talking about is the one from the vault, and it states that the family core is unlocked only by the sum of its digits. Now, when recording the previous episode, I thought that the family core was something hidden within a compartment within the vault, because that made sense to me. Now, after reading your comments, it seems like that the compartment itself might be the core. So that made me wonder, if the compartment is the core, then what's within the compartment? But it kind of makes sense because each compartment has a number associated with it. And by computing the sum of that number, we know how to unlock it. Unfortunately, I didn't get how to insert a code to open these compartments, but we'll get to that in a second. My main problem was that I didn't know which compartment was relevant. But now I realize that when we computed the number core from our family's coat of arms in the wine cellar, that the result, which is 53, and you guys confirmed it was correct, that is also the family core. So we computed the number 53 from the wine cellar, which is the family core. That needs to be used in a compartment within the vault, which is also the family core. And that compartment contains the family core. That's a bit confusing to me. We'll see what it contains. I don't know yet. But anyways, if 53 is the family core, then we can unlock that compartment number 53, with 8. Now, how do we insert 8? That took me a moment to realize, but there's only really one thing that comes to mind, because all compartments have a keyhole, so we do need a key. It doesn't open by inserting a code somewhere, and there's only really one key that comes to mind when we think of the number 8. So we're gonna have to get that, and then go to the vault, and then we'll see what's behind that compartment. All right, to be honest, I'm not sure. I don't think I would have gotten this without your help in the comments. It seems quite far-fetched that the terminology or the term family core relates to so many different things, or maybe it's just confusing in my head. Now, obviously, if you know the game, that's almost obvious to you. But to me, playing this the first time, no idea. Yes, I remember we did get the attic last time, so that we can get started today with a bunch of items. Now, we'll see how useful that's going to be. 1, 2, 3, 4. Oh, that's far away. 5, 6, 7, 8. Okay. Well, we do have a few items already. We have the broken lever, a sledgehammer, and a battery pack. Okay. All right, I'm going to tune the king as well as the scepter to blue, because both the vault as well as the gallery are blue rooms. What confuses me a lot, which I'm not sure if that's actually going to work, blue, oops, that's a bit weird, okay, is that the gallery, it states in the Sinclair's deed or legacy or whatever it's called, in room 46, it states that the gallery will be removed from the pool after a year. So I wonder how you would get room key 8 after a year, if that's not even possible anymore. So I'm not 100% confident if that's the right thing to do, but it seems logical now that I think about it. I think I'll get started with a code check to get it out of the way. Did I check anything last time? I don't remember. There isn't an item. Okay. That's alright. Let's see what we do here. I think I'm going to go for break room for the keys. but then we have to go straight here. Well, Chamber of Mirrors I would like to get on rank 8. I'm gonna get the hallway closet. It's a bit risky. It's definitely risky, but we'll see if we can move past it. Otherwise, this will be a wasted day, but that's okay. Now, before we do this puzzle, let's see if this is actually a wasted day, because this is our last path to continue. We don't have a key card. Indeed, we can do a den. I think that's a good choice. Let's do this puzzle quickly. Oof, okay, we do 10 plus 2 is 12. We round it to 10, and then we square it to 100. Then we divide it by 10 is 10, by 5 is 2, minus 1 is 1. Okay, so we only ever take half of all of these values, and we start here. We take 7, I need a calculator. We start with 7.5, and we turn this around, it means 75, and we round it to 1, which returns 75. Then we add plus 3.5, and we turn this around, which gives us 587. And then we round that to 1, which is the same. Then we add 0.2.5. The thing is, that's not going to work. It's going to be a massive number. How is that going to work? Wait, let me think about it again. Oh, I messed up. When we reverse, we need to consider the decimal point. Okay, I screwed up. 7.5 reversed is 5.7. Rounded is 6. Plus 3.5 is 9.5 is 5.9. Rounded is 6. Plus 2.5 is 8.5. 5.8. Rounded is 6. Plus 1.5. Reversed is 5.7. Rounded is 6. So this might be 6. Yes, okay. I completely ignored the decimal point. That was my mistake. The number was way too high. Okay, let's first try to get into the corner. We can do that with a library. I'm gonna do that. And then here we'll put down a dead-end clock tower so it's out of the pool. Nice. This might contain an item at the top. No, it does not. Alright. That's a cool room. I like this effect when the pendulum swings. And it only seems... See, down here, you can't hear the pendulum swinging. Or barely. But up here, this is the loudest spot here. And when you go higher again, you can barely hear it again. It's pretty cool. So the sound volume is adjusted based on how close we are to the pendulum, it seems. It's cool. Nice little detail. So here I would like to have options. Therefore I'm going to go with the conference room. No items. Then to the left here. Reading nook. And then here, straight would be good, right? Yes, or option straight right. Drafting studio is useless, so storeroom I need on rank 8 still. I'm still gonna put down the storeroom because I would like more items. It is a bit risky. We'll see. The studio would have been a good choice as well, but then we would have been down to 3 gems. And we still need the vault. which costs 4 gems. I want to have enough gems for that when it comes up. Another library. Wait. Oh, because we always get the library here, but it's actually not in the pool anymore. Therefore, I'm choosing the dining room for options. And we'll stay on the rank for now. Oh, the vault. See, I think I have to go for it. I think I have to take it. Then I'm only missing the gallery. If I get the gallery and then I don't get the vault anymore, that would be crap. Security would lose us a door, and this is a dead end anyway, so vault it is. I don't have to enter yet. We do need the key. The 8 key. Okay, trophy room it is. That was a close one, considering these are 2 dead ends. Alright, then straight right. Another key goes to waste here. I might need to choose the rumpus room here. We have a lot of gems. Don't want to waste them. We can't talk to Alzara anymore. Maybe we should look at these prophecies again one day. They were so cool. Maybe they have some additional hints now that we understand the games a bit better. Dude, what a joke. No way. I do think... It has to be that way, come on. I do think the gallery's rarity is automatically, like, tuned higher. Or did I make it more? No, it's still rare. Why do we get the gallery every single time now? Whereas before there were weeks in the game that I haven't seen it. Entire weeks. Now we get it literally every run, I feel like. I think there almost has to be like an anti-bad luck buff or something. Okay, we got the key, and if my guess is correct, we can now use that on vault number 35? No, 53. 53. Now, you obviously didn't... I wasn't able to share my thoughts. Nice. Oh, it doesn't show us the key symbol. It shows us the eye symbol. Oh. Deposit box is locked. Oh, this is a custom. We've never seen... We've never seen this before. An allowance token. Wow. I hope this is something good. Yeah, obviously I wasn't able to really show you my thoughts of how I thought about this, because that was just happening during the last couple days. But let's see what this is. We have like 4 pages here. Wow. So this is the family core, or I guess the family core is the deposit box, because this letter doesn't seem to be the core. So my obsession with ciphers was renewed. Who wrote this? Herbert. Okay. Oh. We have a cipher here. Oh god, I love this. Okay. We shouldn't jump ahead too much. My obsession with ciphers, oh, he even says it's a cipher, was renewed after my brother died, for among his journals I found a curious square. A grid of words written in hand. I immediately recognized my mother's. So, our uncle's mother wrote that cipher. Accompanying this discovery were numerous pages containing traces of my brother's fruitless attempts over the years to decipher this grid. So his brother is my dad. Wait, uncle? Right, my uncle's brother is my dad. I'm so bad at this family stuff. It was a bittersweet find. The excitement I felt was tempered by memories of the unique bond my mother and brother had always shared. I was the child with an interest in puzzles and wordplay, yet it was Simon to whom she bequeathed this cryptic gift. Oh, that was done... Wait. So our uncle's mother made that for us. That's interesting, but that means the cipher was made recently, because we're only like 13 or something. So this was not something that she did a very long time ago. With all respect to my late brother, it became clear after spending time poring over his notes that he was not very suited to this challenge. Occasionally, he stumbled upon some promising ideas, but none of them were thoroughly pursued. Where I will give him credit, however, is in the extensive research he conducted, combining through a career's worth of our mother's notes and correspondence. This search culminated in the discovery of a letter my mother had written a local professor, requesting additional material for use in the creation of a cryptograph. Additional material for use in the creation of a cryptograph. What's that mean? This meager clue was, according to his survey, the only shred of evidence in her belongings that mentioned this project. As for me, I am ashamed to admit that despite all my boasting, I have nothing to show for nearly 3 decades of effort. That doesn't make any sense. So our uncle's mother made this cipher for us, Simon. Oh, or is our dad also called Simon? Because he couldn't have been working on this for 3 decades already if she made that specifically for us. I am no closer to solving this than I was in those early months of daily obsession, and with each passing year I fear my chances of reaching a satisfying conclusion to this adventure grow ever slimmer. Some might say this outcome is quite fitting, poetic justice for tormenting my readers for so many years with seemingly impossible bafflers. While I can certainly relate to their frustrations, I wonder if we really need to obtain answers to all of life's questions. Must we always quench our thirst for knowledge? At my age, I often find myself looking back at the long path behind me, and I think I am content to leave a few stones unturned. A life without some mystery is a life without imagination. So I will lay down this burden and leave this stone and the winding path of intrigue it proceeds for future generations to explore. Herbert. And that is the cipher. Now, what immediately jumps my eye is that these are all 4-character words. We have 1, 2, 3, 4, 5 columns. 1, 2, 3, 4, 5 rows. So 25 words, 4 letters each. So 100 letters or characters. Pigs, sand, male, date, head. Okay, so I have to quickly take a screenshot of that. So that is basically all that I'm getting. So, pigs, sand, male, date, head. Clam, peak, sand, so Joya we know. Toad, cart, will, tape, legs. Tree, road, maid, we know maid. Slab, rock, hand, vase, safe, clay, toes. Safe. So Joya, no, Joya is not a maid though, right? Okay, what is remotely known to us? So we have a mail room. Well, I guess Mount Holly has a peak. And there is the sands of the Black Realm that were like littered in red blood or whatever. Well, the well, is that the fountain? No, they call it a fountain, so it wouldn't be a well. Toad, card. Card? Postcard. He has a will. Tape in the security. Legs. There's lots of trees, including the white ones and the one that's cut down. Roads. There's roads leading off the estate. Slab. Rock. There's rocks where something was buried under. Vase in the entrance hall. And we have lots of safes. Clay, toes, damn. The question is if all of these relate to something, but what would pigs relate to? Now, if it's a cipher, see if it's a cipher, that's the thing. It usually isn't necessarily that much about the words themselves. It is more about like the combination of things. Or wait, what is Pix? Oh, wait. Okay, let's start fresh. Let's find the P words quickly. There's only 2 P words. Words that starts with P. What about S words? M. Maid and male. That's very close. Oh, do we need to do the difference thing again? Where we need to figure out what the difference in them is. So here we have an L and here a D. Sand. Why is sand twice? Do we have other ones that are twice? That's weird. Let's continue with marking the colors quickly. Date. That's the only one. Do we have something that looks like 8? No. We don't. Do we need to shift it? Wait. Date. Dot. Okay, I'm just going through a lot of thoughts right now. It's really weird. So I am to and we have a lot of ants. See, we have a lot of ants. We have a ton of ants somehow. Now the thing is, this could... Okay, wait. Give me another ASCII table. Okay, we have our ASCII table back. Now I'm not sure if that's going to be relevant, but we'll see. P... Wait, I need to mark where the alphabet is. Where's the alphabet? So from here... I can't draw on here, of course. Okay, we only need what's relevant. Now we might need numbers, so I'm going to leave the numbers in. Everything that we delete is less distractions. Okay. Let's just see if that means anything. So P is 80. I is 73. G 71 and S is 83. Oh, don't tell me I have to get the core of this. I was wondering. Wait. Okay, so basically that is pigs, right? Now the thing is, if... Okay, wait. Where is the... where's the core thing? I'm excited. That's a cool puzzle again. I mean, I don't know what the solution is yet, but at least so for now it seems to be a cool puzzle. Where's the explanation of the number cores? Dang it, where is it? Here is the wine cellar. This is where the number... I moved this number core thing, so I couldn't find it anymore. Okay. So what I was confused about, because we only ever had to compute one numeric core so far, the one with the family coat of arms, and we did do this first step, we did do blah blah blah, this second step, but this third step says if the result is a number with more than 3 digits, repeat the above process. That has not been relevant so far, and I was confused at why they would include that hint if it would never be relevant. So now, maybe this becomes relevant again. So the question is, if we get the core from that, and we break it down... Oh, see, it could, because this goes up to 122, right? So it could be any of these letters, and then we would get 5 words with 5 letters each. I mean, I have to try it with the first ones at least. I have to try it. Otherwise, I'm not sure. This seems to be the best lead so far. So take any number with 4 or more digits without changing the sequence. Split that number into 4 smaller numbers. So the problem is we don't know. I would need to write a program for that. Holy shit. I could write a program quickly where you could insert any number. So basically write a function where you could pass in a number, then it quickly decomposes that number into 4 smaller numbers, like here, and it quickly gets every single combination and then does step 2 for all of those combinations, which means it tries all combinations of plus, minus, times, divide, and then simulates all those combinations to figure out what the smallest one is. And then if we have more than 3 digits on the smallest one, we just try it again. But is that seriously the solution? I mean, how many people would be able to solve that if that is really the case? But Sinclair said it is difficult, so it might actually be a very tricky thing. Although ASCII is really not that... Like, if I would have made the puzzle, I would have hidden my own cipher, like how to decode it. I wouldn't have hidden behind ASCII. But since I have not found any encoding in the entire game so far, maybe I've missed it. Or I don't know, I mean, if you have to... See, that's the thing. If this is based on an encoding that I do not know yet, then how would I know what it is? I have to assume it's ASCII. Because if it's an existing one, it's probably that one. Like if it's a real world one. Man, I have to try it. Holy cow, okay. Visual Studio is such a crap program, man. Why am I doing this in Visual Studio? I do not know. Let's write a console app. That makes most sense. We call it Blueprints ASCII cipher. Or just cipher. Maybe we have a different idea later. Let's go. .NET 10. Yeah, whatever. I just want to write a simple program, but it already needs to load an empty project. How is that possible? So, hello world, let's see if it runs. Would not be surprised if it doesn't. Oh, it does. Okay, hello world, press any key. Okay. Well, we start off by reading the line, and then we'll create a function called to decipher. These autocompletes are insane. I haven't even written anything and it thinks to know what I want to do. How does it think it knows what I want to do? What the heck? That's not what I want to do. I hate these autocompletes. Oh, I should turn all of this stuff off, but I don't usually work on Visual Studio here. Okay, we're going to get a number into our function. And then the first thing we need to do, let's write that down quickly. Step 1 is break number into 4 smaller parts. Step 2, assign operations to each part. Kind of guessed it correctly there. Step 3, compute result. So the thing is, because we can break it into 4 smaller parts in various different ways, so we need to do step 2 for each combination. I call it a combination. And then for each combination again, because you can do multiplication and division and whatever in different orders. We need to do compute result, and then in the end we return the smallest result. And then if number, if result has 3 or fewer digits, then return result. Letter, character, represented by that ASCII code. Because I think the result that we're getting is going to be a number, and that number likely is another character. Now, this might all be garbage. And if that is garbage, then today's episode might just be writing a decipher function that ends up not deciphering anything. It is kind of funny though. Okay, so we're gonna do, before we can even start the decipher, so basically what this does, this allows me to type something in my console, and then whatever I type gets stored in this input variable. Oh, actually there's a step 0, I didn't realize. We have to, step 0 is turn word into number. This one we call compute core, compute numeric core. It's more accurate. Okay, so the way we're going to do this is we're going to loop over each character in the input sequence. So if, let's say the input is made, right? So this will loop over each of the letters in that word. Then we're turning that character into an ASCII number. And apparently autocomplete says this is 70, 77, 65, 73, 68. Is that what I ended up with as well? No, because I did it for pigs. It doesn't really matter. Could be true, I guess. Seems reasonable based on the ASCII table over here. Let's quickly check. 77, 65, made. Yeah, this is going to be probably correct. Doesn't really matter. Then I'm going to have to put all of these numbers together into one by concatenating them. We call this the big number, which for now is just, well, the big number is just nothing to start off with, but then we add the ASCII number to it, like this, which will result in this. That is correct. So now we have the big number. We call this the big number. Okay, then we will say we want to compute the numeric core of that big number. Okay, that is step 0 here. So we're going to do all of these steps, and if the result is larger than 3, we're just going to call this compute numeric core again. That's just going to be our loop. And in the end, this will return, well, let's say we want, in the end, we want a potential core. Potential core. We don't know what it's going to be. Let's just say it's going to be 0 for now. What does it say here? If the result is a number with more than 3 digits, repeat the process. So if the potential core is larger than 3 digits, which means it's larger than 999, then we have to compute the core again of that potential core that is larger than our 3 numbers. Otherwise, we can return the potential core. Now, that's the thing. I think what we want is return a single character. Yeah, I think we want to return a single character. Result. So the potential core is a number, and if we do it in this specific way, if we just cast it to a character, it will do that using ASCII. Because when we investigated the Grotto cipher, the arrays where it resulted in array, I already mentioned that I don't think that Tonda would use a code page, so we can just do this. Now, if you have no idea what the heck I'm doing, that's fine. I've studied these code pages for quite a while. Because we had a lot of problems at work with, so I work in e-commerce during the day, and we had a lot of suppliers that send us text that when read by our system would just turn into garbage because we had encoding issues. That's a very common problem for a software engineer. So that's why I know so much about this stuff. And then we're just gonna, in the end, once we're done, we're just gonna spit out the result here. So basically our code goes through here, computes this bigger number, then calls our compute function, which does our thing recursively. What that means is it jumps into this function, it will do all of these steps that we still need to implement, and then it will check whether it's a large number, and then it will just recursively call itself again, do this whole thing again, and it will do that until we get a smaller number, which it will then turn into a character using ASCII and return that in our result function here, and we will write it to the console, and then our program ends. but we need to prevent our terminal to close. Therefore, we need to read another line, so our program waits until we've entered a new line. Otherwise, it would just close off the terminal, I think. So now all that is left to do is this tricky part here in the center, which is tricky indeed. So now the thing is, we want to split this number into 4 smaller parts, and there is various ways we can do this, right? That's the tricky part. We can do 7, 7, 6 and rest. We could do 7, 7, 6, 5 and rest. It's actually kind of tricky just doing that part by itself. What the hell? I mean, I wouldn't know how else you do that if not with using a program. So basically what we have to do is we pick the first number, which is just going to be 1 digit. Then we pick the second number, which is just going to be 1 digit as well. Then the third number, just 1 digit. And then the fourth number is going to be the rest. Then we're going to move to the third number. We're going to shift digits over into the third number from the fourth like that. And then we're going to shift over the next digit. And then we're going to shift over the next digit and shift over the next digit until there's only 1 left. Damn it, that's a lot of combinations. That's like hundreds of combinations probably. Okay, we can make some assumptions because these are all uppercase. Assumptions are good. Assumptions are great. So since these are all uppercase, they are all going to be between 65 and 90. That means all of these numbers are always going to be 8 long. That's not going to be true because if we have this recursive and we go back in again, it might have a different length. Damn it. Okay, anyways, I probably have to write down the skeleton first to make this a bit more... Like, if you have a big problem, you always need to like reduce it into smaller parts, and then once you isolate the individual parts, they become much easier to solve. So let's... I hate these autocompletes. Let's write down the steps individually. So we want to... This is just going to be our recursive function. That's its only task, basically, is to make sure this gets called recursively again. The next step, I'm just going to call it ASD for now. This thing is going to get 4 numbers. 1, 2, 3, 4. And it's going to spit out the numeric core. So we're going to have a for each combination. So this is a combination. We're going to have many of those. And we're going to go over all of them. And we're going to pass them into this function here. This might actually... I'm going to make this a list of numbers. It's always going to be a list of 4 numbers. And we're going to call this get numeric core. We're going to get the core of those specific 4 numbers. Then what we're going to have the smallest core seen. We're going to keep track of the smallest core that we have seen, which is 0 here. We start off with... I think the core can't be negative, right? Especially if we want to turn it into an ASCII code. So it's going to be 0 minimum. So that's going to be the core, the new one. And then we're going to check, is the new core... Oh no. This is going to be int max. Okay, is the new core going to be the smallest core seen? Yeah, okay. Again, smallest core seen is int max, so that's the maximum number that we can represent using an integer. It's like something like 65,000 or I don't even know, something like that, really big. So if the core that we get from this specific combination is smaller than 65,000, but the core also needs to be positive. So if it's larger than 0 but smaller than 65,000, then we're going to say, okay, this is the smallest core that we have seen so far. But we are going to have to continue simulating, so we'll continue looping because we might see a smaller one later. Now for the sake of testing, we'll just put down this sample number. Okay, so we're going to create combinations. Then we're going to have to break them into 4 smaller parts, which we still need to do. I just manually did it for one of them. Then we're going to go through each combination. So that's one combination. Then we'll get the core, which has to be larger than 0. But if it's... And if it has to be smaller than, so it has to be larger than 0, but smaller than we want the smallest one, so we'll just keep looping until we have the smallest one, until we did all the combinations. Then we will have the smallest core seen. Okay, then all of these steps are actually done within here. So we get a combination here. Assigning operations might actually be the easier part of the program because there's only 4 operations. So in fact, I can actually define those. We have add, we have subtract, we have multiply, and we have divide. And the beauty in this is that all of them take a base number and a value. So subtract will be minus, and multiply will be multiply, and divide will be divide. And now we can define a list of functions, which are these up here. Or we call them operations. You could also make an array out of it, might be better. Prefer that. Add, subtract, multiply, and divide. Okay, now we have an array, which is basically a list of operations that we can do. So we can basically now loop over these operations and apply each operation to the value. It makes it a bit simpler. So we know that our base value is always going to be, oh, actually, we don't even need add. Never mind, we don't actually need add because the first number is always add. This might actually not be such a good idea. Okay, so there is an easier way to do it. Simply because we have 4 numbers. The first one is always plus, so that leaves us with 3 numbers and 3 operations. So there's only really, we can do, what are the things we can do? We can do minus times divide. We can do times minus divide. Wait, we can do minus divide times, which is the same, right? Because these 2 times and divide are the same. So it doesn't actually matter. So we could put that here. Then when we do multiply, we can do multiply minus divide, or we could do multiply divide minus. But that's going to be the same as if we were going to do divide multiply minus. And the only one left is going to be divide minus multiply. Is that correct? Are these all? So we only have really 4 different things we can do. I think so. So we have the base value. We're going to get 4 different results depending on which operation we do. And then we need to take the minimum of those 4. Okay, so result 1 equals value minus, well, okay, let's quickly get those 4 numbers. Okay, so I extracted the 4 numbers from this array into underscore 1, 2, 3, and 4. So now what we can do is we can do underscore 1 minus underscore 2 times underscore 3 divided by underscore 4. That will give us our first result. Then we're going to go for the second result, which is multiply minus divide. That's result 2. Then we'll go for the next one, which is times divide minus, and then the last one is going to be divide minus multiply. And then we're just going to return the minimum of those 4 results. This is so annoying because math min only takes 2 parameters. So you have to math min them around like this. So we first get whichever is smaller, 3 or 4, then we get whatever is smaller to 2 or whatever is smaller to 1, and we return that. So assign operations is basically what we did here. Then we'll compute the result, which is basically also what we did here. If result has 3 or less digits, that's here. Return smallest result is here. Okay, so that's actually the easiest part I only just realized. Okay, the hard part is going to be step 1 here. The rest is already done. So once we've split our big number into 4 smaller numbers, we pass them to get numeric core, which we're already doing, which will figure out the small core. But we need to do this for all of these different sub numbers. Now the question is, what's the best part to split them apart? That's really not that obvious to me. I don't want to write a huge program, so let me think about this for a minute. I'm going to rename this function to apply operations. So we have a function called compute numeric core, which is going to split them apart, and then it's going to apply operations, and then it's just going to call itself. I think these are the 3 steps, right, that are written down in the note. That's step 3. Okay, so we're going to make another function here called split number, to which we pass in our number. No, find combinations. We'll call it find combinations. It's going to give us the combinations. Now see, the thing is, if you're a new programmer, you would probably use AI for that. And I totally understand that. But the problem is, if you do that, you never learn how to properly program and your brain rots away. So I will never use AI for stuff like that. I need to keep my mind engaged and operating on the highest possible level. For me, at least. There is way smarter people, of course, but if I start using AI for stuff like that, I'm gonna decline faster than anybody else, probably. Because what I'm doing right now is trying to figure out how I would split this into all possible combinations. Return combinations. Okay. So basically what I did here, we create an empty list, and then at the end we will return it. We just need to fill it now. So I do think we have to start by making starting with the first number being length 1. Okay, that might be interesting. Let me see. Number 1 length equals 1. So the first number is going to be 1 in length, the second one as well, and the third one as well. The fourth number is going to be however long the base number is, minus 3. So the base number, which is this, minus 3 would be 1, 2, 3, 4, 5. So that would be 5 long. Okay. So then basically what we're going to do is we're going to subtract, so we compute the core of this, and then we subtract a length from here, and we shuffle it through all of the other ones, these two, and that one, until this is only 1 length. Maybe I have to paint that quickly. I don't think that's understandable at all. Also interesting how the vault is still playing music. Usually the music stops, no? Or maybe because we're intended to spend forever here in the vault because we get that cipher. Anyways, so this is our base number. So what we're going to do, we set that each of the 3 first numbers is 1 in length. Then we compute the core of that, and then I'm going to basically reduce the length of this by 1. That moves 5 over here. Then we compute the core of that. Then I'm going to, maybe I have to now shuffle 7 over like this, and then we do this until the last number is only 1 digit long, like this. Then we have tried every combination where these first 2 are only of single length. Then we're going to continue iterating, but we're going to make the second number 2 in length. So basically what we have is we had 1 length, 1 length, 1 length, and the rest. Then we did this, we moved to, maybe I should separate this more. Then this was second iteration, where we started filling up the third number as much as possible until the last one was basically only 1 long. Now we'll start filling up the second number until there's basically nothing left, like this. And then we'll do the whole thing one more time for the first number. And then we have all combinations. So that's why I have these numbers here. Now we need a couple nested loops for this. What's the max length? Okay, let's first compute max length of... The max length of a number is 5. Because if it, or, well, yeah, in the beginning, later it might be different because this number might get smaller. But even if this number gets smaller, that's already considered now. This might be 1 as well, actually. So for each, no, actually, let's do a for loop out of this. For length equals 1, but length must be smaller or equal to max length, but every time we actually increase length. Okay, so basically what that does, this for loop here, we declare a new variable called number 1 length, and it starts off with 1. Then it continues looping until number 1 length, while number 1 length is still smaller than max length, which is 4 right now. 5 with this number. But every time it loops once, it will add 1 to itself. So it's going to be 1, 2, 3, 4, and then 5. That's the last loop. And then it's going to be 6, but 6 is bigger than max length, so it's going to exit. So that's for the first one. Now we need to do that for the second, for the third, and for the fourth one as well. It's going to be a bunch of loops inside of each other, and we don't actually need that anymore now. So now here within, this is actually going to run quite a few times. I don't know exactly how many times, 5 squared probably or something, I don't know. In here we can build the combination, and we do this by declaring an index which is 0. So we're starting to read this number from the 0 index, which is the very beginning of the text, so here basically. And the first time we go in here, oh, actually that's a problem now. That's wrong, I made a mistake. So if we would make it this way, then the first time we come in here, all of these lengths are going to be 1, so 4 in total. So we would only cover this part of the string. That's incorrect. And the fix here is that we need one less loop because the last number just takes up the whole rest. So we don't actually need number 4 length. So we're starting off with index pointing to 0. The first number is going to be, we take the original number, we take a substring of it, we start at 0, and we take the length of the first character. Then we advance our index by that length. So the first time we enter, this is going to be our first number. That's what line 54 is doing. And then we advance our index, which is currently pointing at 0, to the next. So over here. Then we do this 2 more times, and we get number 2, and we get number 3. And then number 4 is just going to be the rest. So we don't actually need a length for this one. If you do substring just with an index, it's just going to read until the end. So number 1, number 2, number 3, and then this is going to be the last substring here, reading the rest. And then we just basically parse all of that. Int parse basically turns this, because this number 1 is actually text right now, so string is text. This is actually text. So when we do substring, we get text, but we don't want text, we want the number. So I have to do int parse, which turns the number in text into an actual number. It's a bit confusing if you've never programmed, but there's a difference between whether you refer to one as text or one as a number, because on one you can do math and the other one you can display. It's not the same. And then number 4, okay. Now, just because I'm curious, I want to know how many combinations we're actually talking about. So combination count is combinations.count. And we're just below 100 lines of code right now, which is a lot for what it's supposed to do. I'm sure there's a way faster method, but now let's see what's happening when I'm running this. It's probably going to crash because that's usually what happens. Oh, it's not prompting me for, it's not asking me about what to do. So let's write a query first. Please insert your word. It doesn't actually matter what I do here, it just looks a bit nicer when we record it here. So now here, please insert your word. So our word is made. Okay, we have a crash. Oh, okay, I see the problem. Because we try to... we always read number 1 length here, which is of course wrong. We need to read the length of each of the numbers. Let's try again. Made. Boop. Wrong. So what index do we have here? 4. Index 4 refers to 0, 1, 2, 3, 4. So the text still is 4 at size. But this is 5 though. Wait. Index is 0. Of course it doesn't work. Because right now, I'm always going from 1 to max length. That means we actually go... We try to grab 5, like let's say 4, and then we try to grab 4 again, and then we try to grab 4 again, and then 4 a fourth time, but there's not that many letters, right? So I need to actually, this needs to be a little bit smarter. I can't just loop here until we reach max length. We actually need to, well, we can do that, but if at any point we overshoot the original length of the number, we need to abort, because that's not a valid combination. Basically how we can do this, we can say total length. So we add all lengths together, and the last one needs to be at least 1, like the 4th number. Also funny how I wrote number instead of number everywhere here. It needs to be at least 1 character, the last one. So let's say, for example, if we have 4, 4, and then 4 again, which is 12, plus 1 is 13. So total length could be 13, but if total length is bigger than the input, then we just continue with the next iteration. We don't try to compute it. Let's see. Made. No. What's the start index? 9. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it can only go to 7. Wait, what did I do here? Total length is 6. 3 plus 1 plus 1 is 6. So how did the index go to 9? So index is 0, and then we add 3 to it, so it's going to be 3. Then we're adding 1, it's going to be 4. It's going to be 5. So how can index become 9 here? Ah, same mistake. I'm doing plus equals number 1 length. I need to, of course, do number 2 length and number 3 length. Okay, I was confused. How can we get 9 out of this? Made, again. Combination count 35. The numeric core is nothing. So that ended up with 35 different combinations. In fact, let me quickly write that out. Okay, so we add the combination to our list, but then we also print it out so we can actually see it. So let's see if that makes any sense. Made combination 776. Yeah, it looks beautiful. It's beautiful. I love programming. It's so fucking beautiful. 776 and this 7765. Blah 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 blah. This looks beautiful. It does it a little bit differently than I drew it, but I think that's fine. It then shuffles. Oh yeah, it actually does it basically the exact same way I drew it down, right? It then moves this to 2 digits and goes down until 1 digit. Then it makes 3 digits and does that. 2 digits, 4, 5 digits. Beautiful. Beautiful. This is fucking beautiful. So we have 35 is the combination count, but the numeric core is this. Now the thing is, oh, it's a colon. Okay, see, the numeric core is colon. That's because colon is 58. So the core ended up being 58, but when we translate that to a character, it's a colon. That's why it says the numeric core is colon. Okay, I need some extra debugging here. I need some extra info. Okay, let's go through this again. Please insert your word. Then we read the word from the console. Then we go through each character in the inputs, which is MAID. We get the ASCII code out of each of those, which is always 2 digits, so we end up with 8 digits here. Then I would like to print that out. Your starting number is the big number. Then we compute the numeric core from the big number, we get a result, and then we say the numeric or your numeric core is this. Now I also want to have this as a numeric representation. For that we have to cast it back to a byte. Or I could cast it to an int, I guess that's fine too. I'm going to cast that to an int as well. So in order to compute the numeric core, because this seems to be right, find combinations, we first find combinations from the number. This prints us, hey yo, here are your combinations. This seemed to be correct. 35 combinations seem to be correct. Then we start off with the maximum number available, which is 65,000 something, and we apply operations. I would actually like to know which combination was chosen. Now the thing is, we have a problem. We do have a problem because apparently with that number, it is possible to get a core of 58. That's very low. So unless I wrote a bug, this is not what they intended me to do. Oh shoot, wait. Are there more operations? Minus times divide. Oh, I'm so dumb. I thought it doesn't matter whether I do minus times divide or minus divide times, but of course it matters because we're multiplying and dividing by different numbers. Shoot. Okay, actually there is more to it then. But I don't think that matters because even if I fix this, I'll probably only end up with an even smaller number. And that smaller number is not going to be a letter. It has to be it could be a number, but I would have expected it to be a letter, damn it. Okay, so result 2 is going to be minus divide times, and result 5 is going to be a divide times minus. Okay, then we need a few more of these here. 5. So 1, 2, 3, 4, 5, and 6. Okay. Do we have all operations now? We begin with minus and we swap the last two. Then we do multiply and we swap the last two. Divide and swap the last two. Okay, let's see if that ends up being an even smaller number now. Your numeric core is still colon, which is just a numeric value of 58. Okay. I'm going to wrap this top layer into a function, decipher word. And then on the top level, we can do a while loop, which basically just loops until forever if we say true. We're going to read a word always, and we're going to put that into our decipher word function, which gives us a result. And then we can have that text where we add that character to it. So basically what I did here is we start off with an empty text, then we loop forever, and we ask the user to insert their word. We're going to decipher it, this is basically what we just wrote, and then we're going to add it to our text, which is empty in the beginning. And then we just keep doing that. And every time we do that, your result is, we're going to output what our result is. So let's see what happens when we say, please do pigs attempt to divide by 0. Ugh, that's annoying. Yeah, okay. The 0 needs to be needs to get special treatment. So we need to do result equals. So if under 4, if the fourth number is actually, so basically what we do is, because we're dividing by the fourth number here, so if the fourth number is 0, we're getting the maximum integer value possible. That's just to make sure that when we get the minimum value out of all these results, that result 1 will not be taken into consideration. Otherwise, we just do the normal operation and divide by a non-zero number. Here we're dividing by _3, and here we're dividing by _4 again, and here by _3. Then here by _2, as well as here. Okay, so every time we divide, we need to make sure it's not null. Okay, let's try it again. The first word was pigs. Your result is Y, okay? Sand. Your result is Y semicolon. Male. Okay. Date and head. It doesn't seem to be correct. I don't think I need to log each combination anymore. I think I'm pretty confident in that now. It's a bit weird that in the end it's a question mark, but it doesn't display that here, but I think that's something about how the console works. So I made the whole thing a little bit more beautiful quickly. But I don't think this is what we need to do. So let's see what clam turns out to be. Clam turns out to be the number 7, and toad is R. What if we do pigs and male date head? That's too big. That's not going to be it. Now I'm thinking, what if we have to continue doing this? So we get numbers out of this, right? Wait. So the first word is pigs. Oops. Pigs. The result is Y. So that's 18. Why can't I paint here? It's 89 and it's a Y. Now the next one is sand. That's 59 and a semicolon. Then we have male, which is 64 and an at. Then date. That's this question mark thing that keeps getting screwed up. I think head. No, head is question mark. Wait, what? So this is a question mark, and that's digit 63. But what is that here? 7. What's 7? Need these pieces back. 7 is bell. See, that is so dumb. The character 7 is a bell, so you used to do that when when someone sent you an email back in the day, and they could send you that specific character or something, and when your computer read that character, your computer would do a beep, which is stupid. I don't know. It probably had a function back then, maybe to let you know that there was a mail coming or a piece of paper being printed. I don't know. I'm too young for this. I'm gonna change this around so that we can see the number core first and then the letter in brackets, because otherwise this gets cut off in a weird way and I don't actually know what the core exactly is. So let's try that again. Pigs, sand, male, date, head. That's 27. What's 27? 27 is escape. That's when you press the escape key. So now the question is, if that is another number, so basically this row, when we get the core of each of these, turns out to be this number. It's a huge fucking number. It's huge. Man, I don't think that's anything. All right, I had to get a refreshment here. That's definitely not the solution yet. So what I can also do, in case we need those cores again, because as I said oh, this is still running. As I said in the beginning, I'm very confused that part 3 of this whole core computation has never been used before. So I do believe that we need those cores again. And I really don't like computing them, so I'm going to extend that program that I can not only insert a word, but also a number, and we're going to call this input. And then I'm going to check whether my input is a number or not. And then we create a new function called decipher number, because here we get the big number. Your starting number is this. And then we basically just put that in here and we just do this. All right. So I basically just factored out this small part here. So we can now either decipher a word or we can decipher a number. The word basically just splits itself up into a number and then calls decipher number. But if we end up inserting a number to begin with, then we can now just call decipher number directly, and it will skip the whole word part. That means, all right, slight refactoring. So that means we can now start this, and when we go back here, we have our number, which says 89596427763. Oh, it's too large. Oh no, that is a massive number. Okay. Not sure if we really have to deal with numbers that big. Seems very odd. I don't think that's the solution. So this whole program, well, we might be able to use it again, but it seems like that's not the solution. So we don't have to use ASCII at least. What did they say in the text? This search culminated in the discovery of a letter my mother had written to a local professor, requesting additional material for use in the creation of a cryptograph. Is a device, system, or mechanism to translate regular text into secret code cipher, vice versa. So she needed material to create one of these. I've not seen... Well, it looks like a clock to me. But the clock only has numbers on it. What material would she need? Yeah, so I'm assuming it's not ASCII. But actually my tool might still be useful if we can figure out what the actual encoding is. But I think I have to look that up because I have no idea what the encoding would be. All right, so turns out that there is indeed another encoding that I wasn't aware of. I don't know how you're supposed to identify that. It's rather tricky, I would say. So maybe you can already see it. Or you probably maybe know it in case you have played the game. There is an encoding hidden here, imagine. So let me try. I just know that this is the encoding. I don't actually know exactly how it works. So we're gonna have to try to figure that out. Makes it a bit bigger and like that. Okay. Okay, so what I did, I took each letter and I converted it to an ASCII code, which ended up always being a two-digit code. But I think what we have to do is we have to take each letter and convert it to a number displayed here. Now the problem is we can't go by color. So if you want to know P, we don't know if that's 7, 4, or 1. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, okay, interesting. So these have the same colors respectively. Now what if we duplicate this? Oops, what if we duplicate this and add it to the back end here? Then that's not the same colors anymore. So if that is 10, if J is 10, then L is blue, but it's 2. So I don't think it just continues. It probably... Maybe we just continue counting. Wait. Screwed up. Let me paste that in here somewhere so I won't lose it. But then I need to paint a little bit again. So if we grab this and if we assign numbers to this, 1, 2, 3, 4, 5, 6, 7... It goes up to 24, right? I would assume. 12, 13, 14, 15. Maybe not the best picture of that room. Oh no, it goes to 26. I can't ever remember how many letters are in our alphabet. So 26. So interestingly, okay, actually some of these end up being... Yeah, it's just different encoding. It's actually so simple. This is basically the simplest encoding you could think of, right? Because you just count, based on the alphabet. It's probably a name for that, like alphabetic encoding or something. And I can actually include that very easily into my program. So when we get a word, we get so what I need, okay, wait, I need to explain this. People won't understand if I don't explain this. So we know based on the classroom that the character A is encoded using the number 1, right? So if we want to know, let's say we want to know what the M in mate, what number that is. So if we check our thingy here, that is number 13, right? But if we just get the ASCII value, it's actually 77. Now, how do we get from 77 here, which is what I'm doing currently, to 13, what we actually want? It's actually relatively simple. We just get the ASCII value of the A, which is 65, and then we subtract 65 from 77. Basically, we offset the M all the way back to here, well, to 13 actually, so to here, by doing minus 65, because that gives us 12. Then we just need to do plus 1, because this starts at 0 and not at 1. So we get the ASCII value. Okay, let's do that. For that, we need to know ASCII A equals... we need to get the integer value of the letter A. That's going to be 65. Well, actually, this needs to be a char. And then we just ASCII number. Let's call this alphabetic number. That's the one they use in the game. So we take the ASCII number. We subtract the ASCII A and we add 1. I don't know if that's going to work. Okay, what is that going to give us? Well, it basically gives us the same. Wait, let's just try it again. I'm confused right now. I've been thinking about this for too long. By the way, I've been recording for about 2 hours now. I don't know how long the video is going to be. I don't know how I'm going to cut this in the end. I'm not sure how interesting it is to write that program, but I guess I might include most of it. We'll see. Pigs, sand, male. Hey, why is it doing the same again? Wait, this is wrong. Oh, alphabetic. No, I used the wrong one here. I still used the old one. Okay, let's go again. Pigs. What is that character? That's definitely not what... Oh, yeah, because I'm... Okay, so I get the core in the end, and then I'm using ASCII to translate it back. Oh, I'm an idiot. Okay, I need to not use ASCII, and instead I need to use the alphabetic thing again. So when we get... let me think about this. We compute the numeric core, which is this number here. Your numeric code is... your numeric core, so that's the core. So the core, let me see again how it looks like. Pigs. It's 15. So that's way too low, right? So now we need to add, let's quickly see what's 15. So 15 is an O. And when we look at ASCII, where is ASCII? An O is 79. So we want to end up with 79. So we take the core and we add the ASCII A, which is 65, but then I think we need to do minus 1. So 15 plus 65 minus 1 should... 65? Yeah, that should give us 79. Let's see. Pigs. I used the wrong thing again. Letter, return letter, letter. Okay, pigs. O. Okay, good. Now we have an O. Let's continue. Sand. Oak. Male. Okl. Doesn't look very good. Okle. Head. Now did I make a mistake is the question. So P is 16, that's correct. Then I is 9, that's correct. Then G is 7, is correct. And then S should be 19, that's correct too. And if we get the core of this, it's gonna be 79. Well, okay. The core is actually not 79, the core is actually this. Let me check again. The word pig. Yeah, the core is 15, and 15 turns out to be O. Or do I need to pretend that they are all 2 digits? Shoot. Aha. Or I'm making it way too complicated. Yeah, maybe I'm an idiot. Maybe this is not one number. Of course. It's the same as on the coat of arms. These are 4 individual numbers already. So I don't actually need to figure out what the combination is. Let me try that quickly. So this whole crap here about figuring out what all the potential combinations are is actually garbage. I need to rewrite this. Because I stringed it together so that it would be, the word becomes one number, but that's not actually the case. I see. Because the word is, yeah, okay. So basically here, instead of stringing everything together to one number, I'm gonna have to make 4 numbers out of it. And then I don't need to try to find the combination because I'm already gonna have it. Let's try that. Oh, I mean, if it's not that, then I have to check a clue again. Okay, let's see. I'm just gonna make this it's gonna be ugly and whatever, but it doesn't matter. Get a number word, and then we're here in this function, we're putting in the whole word, and we're saying which character, which index we want, and then we're first getting the word from the word. We're getting 1 character at the specified index. So now we can do word 1. So the first letter is going to be this, and the second letter, and the third, and the fourth. And then from that we will compute basically of the letter. We get the ASCII value of the letter. So for example, M in maid, that's going to be 77, and then we minus 65 plus 1 gives us, I don't remember, 15 or something like that. Okay, so this is the second letter, the third, and the fourth. But these are not actually the letters, these are the numbers displayed in the schoolroom that refer to that letter at that index within that word. Okay, then we don't actually need to do this big number thing. We don't need to loop over the word again. We don't need to know the big number. Well, we could do something similar. We could say, just to verify, your numbers are, and then we just paste all of those in here. So we should get 4 numbers between 1 and 26. Then we say decipher number. And we say first, just put second, third, and fourth in here. Then we don't actually need to find combinations anymore. We know the combination. So we can say apply operations, which results in the core. It's all a bit hacky, but it's fine. We just don't need to... we just can simplify this. Not sure if I want to do this recursive anymore. It gets a bit more complicated. Most of that stuff we don't actually even need anymore now. Okay, I have to change the opening a little bit here. We're only going to do this with the word. We're not going to do this number thing anymore. Okay. I'm off by 1 because the first letter is actually at index 0. Index 1, index 2, index 3. Okay. Okay, let's see. So when we do pigs, we get... minus 132. Now we get minus again because I didn't properly account for that anymore. So let's say if result 1 is smaller than 1, then we're just going to assign the max possible value to it so it won't be considered. This is an easy way to just take it out of the equation. It's not beautiful, but I think it's going to do the trick. So if any of these numbers result in negative, then we probably won't, we won't consider them. Okay. That's something new. What was the thing again? K, P. You haven't saved your work in 90 minutes. Okay. Mail, date, head, KPMDG. Your numbers are 13194. Is that correct? 13194. That results in maid. I didn't want... I made a mistake. I started with maid. Why did I start with maid? I'm getting tired now. It's a bit late by now. So let's see. Sand, mail, date, head. APMDG. That does not sound right. So for pig, we have 16. Yeah, here, 16p. I is 9. G is 7. S is 19. That's an A. Your numeric core is 1. How did we end up at 1? 16 minus 9 is 7. I might do, shoot. See, the problem is in computers, when you, for example, do 1 divided by 3, that gives you 0.333, right? But computers will just round that down when you're dealing with integers. So some of these results here might actually contain decimal numbers, especially when we, where is it? When we divide by, like things like, let's say we divide by 19 as in pigs, we might get a really tiny value such as 0.156 or something, which then gets rounded down to 0, and then we add the ASCII A, which is 65, and that's why we end up with an A here. I'm sure that's the problem. So what I need to do, I need to use decimals here. I need to work with decimals so we get proper decimal values and it doesn't round them automatically. What's the problem here? Then I'm just quickly gonna print that out so we can see what the minimum is. And for now, I'll just still round it down to whatever it ends up being. So when we do S, yeah, I need to insert a 4-letter word. Yeah, see, your minimum is some crappy value. That gets rounded down to 1. Yeah, okay. So basically, we need to not take any result that is not a natural number or like a non-decimal number. So we do that by doing a modulo 1, which basically we take the value, we divide it by 1, and we want to make sure if the result is 0, that means there is no remainder, which means it's a full number. In that case, we can use it. Otherwise, we're going to use the maximum number. Okay, and we're going to do that for all of them again. It's getting a bit nasty here. I'm not even sure if I'm on the right track. Oh, this episode might be quite something. How long have I been recording? Damn it. Ooh, it's going to be tricky to edit that properly. Let's see if that is even correct what I did. Sometimes we make some weird mistakes. Indeed, this ends up being a massive number. Forgot to properly use the correct variables again, as always. Copy paste error. Let's see if that fixes it. No, massive number. Why are these numbers also freaking big? Okay, that's confusing me now. You know what? There's an easier way. I think this modulo thing is kind of weird. So let's see if the result is equal to the result when we cast it down to an int, then we can take it, because this will round it down. And if that's equal to the original value, we know that it's a full number without decimals, and then we can use that. Otherwise, we're going to use the max value. Maybe that makes more sense. Just got to use that for all of them now. Pigs. I'm very confused right now. It seems like these all result in a decimal number, no matter what I operate them on. Did I make a mistake? Alright, so there might have been a bug here because I used casting to an integer, which rounds down and potentially overflows. So I now used flooring, which should be better. Now we're checking whether the result is equal to its floored result. If that's the case, it's a full non-decimal number, which we can use. It still doesn't like it though. All right, let me show you the part I don't understand. I've put a breakpoint here so we can actually investigate what the values are that my program is dealing with. So if we're doing minus times divide, we end up with 12.6. Okay, that's not a good number. If we do minus divide times, we end up with minus 8.4. Here, 143.6, 1.5, minus 6.5, minus 131.2. None of these values are useful. What am I doing wrong? 16 minus 9 is 7. Divided by 7 is 1 times 19 is 19. Why can't we get to 19? Wait. 16 minus 9 is 7. Divided by 7. So minus divide times, where is that? Minus divide times. Why would that result not in 19? So we have 16, 9, 7, 19. So if we do 16 minus 9, that's 7. Because of operator precedence. Oh, that's so stupid. Because in blueprints we have to do it from left to right. Do we though? So what the compiler does here, it does first the multiplication, then the division, and then the subtraction. Now, is that how blueprints works, or do we need to have a left-hand precedence that we first do the subtraction? I don't know. Let's see what happens if we force precedence by using brackets. It's a bit annoying, to be honest, to type that stuff, but it is what it is. I like the puzzle though. I mean, I don't really like that the cipher is hidden away in the schoolroom. It's very weird. I would have not figured that out. But that's the typical blueprint stuff. Something is hidden so implicitly that you basically don't find it. Now, what are we getting now? Now my minimum is 19. Interesting, okay. Please oh, it's S now, okay. We've not had an S here before. Where is my... Here. So S, sand, male, dated. Still. That's a word. Still. That's a word, people. That's a word. Let's continue on. Clam, peak, sand, Joya, well, still water. Toad, card, wheel, tape, legs. Still water tints. Tree, road made slab rock. Still water tints blank. Can you read it? Yeah, I mean, it's probably hard to read, but... Here. Still water tints blank. Blank. Hands, vase, safe, clay, toes. Oh, no. Wait, what did I do? Toea. No, I meant to write toes. Okay, so instead of an A, just ignore that A here. Still water tints blank books. Okay, so that's cool. So that must relate to the secret passage, right? That's a blank book. But what's still water? Tints blank books. Okay, so I'm pretty sure that the book will be tinted blue. If we put it in water... Oh, because water is blue. So if we if we put the book in water, in still water, like the fountain, or the reservoir. What's still water? Why is it still? But I can't take the book. I can't interact with the book, so I need to bring the water to the book. Which I can do with the watering can. I remember one of you in the comments saying something about the watering can still being relevant for something. And I was never able to use it for anything, so maybe that's it. Still water, but why is it still? Why is it still? Do I need to fill it up using water in the reservoir or something? Okay, well, that's cool. Still water. I need to write this down quickly. Where do I write this down? Here. Still water tints blank books. Why books in plural? Probably just so to make sure it's 5 letters. But why still? Okay, I guess we want a secret passage. It's like 4 in the morning now. I didn't actually wanted to make a short episode because next Monday, a demo is coming out of Jonathan Blow's new game called Order of the Sinking Star, and I will be playing that for a while. Now we're going through the gallery. Oops, I should actually have probably gone here. Yeah, I'll play Order of the Sinking Star, at least the demo. It'll be out for a week. And apparently there's 100 puzzles in the demo. So I will be playing that, and we're going to make a series about it. I'm going to try to finish the demo in a week. which is a lot of time. It will take me a lot of time. There will be several Order of the Sinking Star videos over the next couple of weeks. And then since the demo will be offline and I won't be able to play the Order of the Sinking Star anymore, we will just do blueprints. We'll finish that up. I hope we're not too far from the end, to be honest. Let's change this to orange now because I want the secret passage. We still have monk for 2 days. Let's try to get the secret passage and then sleep in that. We have a key 8 that I don't want to use. Where are we? I'm gonna get a foyer and then maybe we can get a secret passage soon. West Wing Hall. So yeah, if you're into this type of puzzle game, then definitely check out The Order of the Sinking Star. It's going to be an amazing game. I can already tell you that. I followed the development a little bit. I'm going to try to get the corridors out of the way so we can get a secret passage. And the whole game will have about 1,400 puzzles and hundreds of hours of game time, play time, which is going to be insane. But the demo is just going to be 100 puzzles. So we'll see. So definitely check that out. The first episode should be out on Monday night probably. I think I'm just gonna put down orange as much as I can, really. Here I would need to go straight. We cannot go straight. I can redraw though. I don't really want to redraw, so maybe let's get some more keys. We're gonna have a key card problem as well soon. So we can also do a utility closet. Okay, we're getting a few things here, none of which I actually want to use, so I'm just gonna place down the tunnel to get rid of it. Okay, and then let's see what we have in these holes here. That's it, apparently. What are we getting here? Hallway. Terrace. Maybe I'll place a terrace, because then green rooms are free, might help us. Didn't see if there was an item there. There is not. Okay. In that case, we'll move on straight, hopefully for a secret passage. Let's go gift shop for more paths. Here, straight left. Let's not use that yet. Secret passage. That's nice. Okay. So now we're getting to rank 8. So maybe I'm gonna go for green. Maybe we'll get a cloister. Maybe aquarium. Doesn't really matter. And then maybe we can do a few more blue rooms here before we go to sleep. On rank 8 here. Let's go. Workshop, music room. We do not need those. So let's go hallway. And hallway should... No, not yet. Key. Let's see what we're getting here. Parlor, we do not need that. So I'm going to redraw. I would like something else. We're not getting anything else. So it's going to be Great Hall. And in the Great Hall we get a dig spot. This animation takes so long, it's insane. Great, 40 coins, thank you. Not that I would need that. And then here, what are we getting? Nothing of relevance. I think I'm gonna go treasure trove then. Maybe we can open that in a minute. Then to the right here. With a observatory would give us a star. Then we can get closer to the 88 stars that we still need. We have 64 now, so we need 24 more. Apple, more 4 rooms. That and that, okay. I think I would like to see that constellation, so I'm not really going to use the inkwell. So here to the right, can I use the 8 key? No, that doesn't fit here. Okay, then regular key. We'll go with the music room. And we'll still have 4 gems. Okay, that's not too useful. Alright, so here, last chance for a blue room. We could do room 8, but I don't need that anymore. We've already looked at it. We've already looked at all of these as well. It's a bit of a bummer. I'm just gonna place, doesn't really matter, parlor, whatever. Okay, so no new blue memos today, unfortunately. But we still get to open this. Fen Ares borders a poetic realm, so that's important for the sigils. Which I kind of brute forced. Okay. Well, it would be good if I can get the lucky rabbit's foot to get rarer items to spawn. Shoot, how would I get that? Where would I get that? We could do mailroom, which could give us a lucky rabbit's foot tomorrow. Oh, I have to put the lucky rabbit's foot in the code check probably. Next time when I get the chance. I have 20 steps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I won't make it to the code check and back, that's the thing. Oh, this is so annoying. Okay, well, I'm gonna go for mailroom. Probably isn't anything in here. And then we hope that we can find a lucky rabbit's foot in the next run. Which increases the chance to get items, which probably include the watering can. Which usually spawns in the greenhouse. And in order for the greenhouse to contain more items, we would need the veranda, or how was that? Here, yeah, we need the veranda and then the greenhouse. So we're going to use the king and the scepter to wish for green. We're going to make our way over to green. Then wait for a veranda. And then put down a greenhouse. And if we have the lucky rabbit's foot, we might not need the veranda. Dang it. Okay. Wow. Man, that was quite the episode today. I actually really liked that puzzle, except the part where the encoding was hidden in the schoolroom. I don't know, that was not something I thought of at all. Especially given the grotto puzzle used the ASCII encoding and now suddenly we needed a different one, but it is what it is. If you've enjoyed the series so far, be sure to subscribe to the channel and leave a like, that would be much appreciated. If you're interested in a huge, massive and amazing puzzle game, then check back on Monday night when I will release the first episode of The Order of the Sinking Star. More episodes will follow soon after. I see you in the next one. Take care. Bye.